Welcome to Ask and Learn.
Okay, so in this question 76, we have a coaxial cable, and with a graph, figure 35, which I'm not including over here, but pretty much what happens is that you have a couple cylinders, and the inner one has the radius RB, and one other one has the radius RA. You have some dielectric material inside. This is actually what all of the wires are like. So let's look at the question. Question A says determine the expression for the capacitance per unit length of a cable whose insulator has dielectric constant big. Okay, so not too hard. This is a cylindrical cylinder, and we already know the formula for these type of things. So if you walk through example 24.2, example 2, you will know that for a cylinder, we have the the capacitance per unit length is 2 pi epsilon naught over 1 out over R in. Okay, but here we have this extra factor, so we're adding this here. That's part A, and part B. Part B says, what is going to happen if we have all of these numbers for a kind of cable, and we suppose there is a potential difference of 1 kilovolt. Find the capacitance per meter cable. Okay. It actually, it's not clear why they tell us it's 1 kilovolt, because we do not need that number at all. Because like voltage doesn't appear in this equation. So we're going to use all the other numbers to give us. We need the constant. We need the radiuses. Negative 12 times square times Newton meter square times K is 2.6. And then we have 9 over 9.0 millimeter over 2.5 millimeter. That gives us 1.1 times 10 to the negative 10 farad per meter. Okay, so that is the answer to this question.